Voltage divider rule.
What is the voltage divider rule and how is it applied? The voltage divider rule only applies when there are two or more resistive elements within a circuit connected in series. The voltage divider rule uses a ratio, and this is due to Ohm's law, as the current through a series circuit is constant, whilst the voltage is subjected to change depending on the resistor's values. It is noticeable within the latter example that the potential difference across a higher valued resistive element is greater. This is all due to Ohm's law, where the voltage drop is directly proportional to the size of the resistor. Now time for an example. In order to calculate V1, we first need to find the total resistance of the circuit. To do so, we add all the elements within the circuit together. In this example, we add the 5 ohm to the 12 ohm, and then finally the 8 ohm resistor, giving the circuit a total resistance of 25 ohms. Now to calculate the potential difference across V1, we can use the above formula shown and sub in the known values. In this case, our E value is 10, which is then multiplied by the resistance value that we are finding the voltage across being 5 ohms. Then it is all divided by the total resistance previously calculated of 25 ohms, giving us a value of 2 volts for the voltage drop across R1. This same process can be used to calculate the voltage drop across R2 and R3. To check our previously calculated results for the voltage drops around a circuit, we can use Kirchhoff's voltage law, which deals with the conservation of energy within a closed loop around a circuit, stating that the sum of voltage rises and falls around a closed loop circuit is equal to the voltage source, which in this case we can add V1, V2 and V3 together, being 2 plus 4.8 plus 3.2, giving a voltage of 10 volts, which is equal to our source voltage, meaning that our calculations are correct. So what is an application of the voltage divider rule? A potentiometer is essentially a variable resistor which can be used to create an adjustable voltage divider. A potentiometer consists of 3 pins, with the outer 2 pins connected to common ground and a voltage input, whilst the middle pin simulates a voltage divider using a wiper arm that runs across the variable resistor. Turning the potentiometer one way will decrease the voltage and may even go to 0, whilst rotating it in the opposite direction will cause the voltage to increase, approaching the input voltage.